Hi everyone, Dave here. In January of 2026, I was contacted by Aferiy and they wanted to know if I was interested in reviewing one of their solar generator products. Well, I wasn't able to do it right then, but I followed up with them and I went ahead and accepted a demo unit, and I'm going to do a product review for you guys and a stress test, and we'll see if this thing is any good. I'm not riding the money train on this one, and I'm not going to be paid any sales commissions if these units are sold, and my hope is that if anyone does purchase it, they will save a little bit of money by clicking on my link. But remember, I don't get a dime. I will be giving you my honest opinions of this unit and sharing my honest experiences. Now let's briefly mention the price. It's around $1,000. You get about 3 kilowatts of electrical storage, but you also get an inverter and a charge controller and a nice display on the front and a set of wheels, so this is really a high-powered mobile solar power solution. My main challenge and concern with these kinds of machines is mostly the long-term durability, the warranty, and support, because all of them have their chances of failing as they are complex electrical machines, and there's a lot of moving parts inside and things that can go wrong. So I can't do a long-term test right away. That takes 2 or 3 years. What I'll do is a short-term test where I push this unit really hard and we will see what it's made of. If you've seen any of my past solar generator and inverter tests, you may have noticed that I'm not exactly very gentle with them, and I tend to push equipment extremely hard, much harder than the average person would, not because I want to destroy it, but because I want to see, can it take some abuse and is it durable and well made. If it makes it through my initial testing, then I feel there's a better chance the product is durable and high quality and should serve people well. Now, one of the primary things that caught my attention about this machine is that it has a knob on it which allows you to control the charge rate for the battery. It is rather unique and novel, and I've not seen any other company come out with this idea as of yet. Well, there it is. I guess I'll go ahead and start unpacking this thing and I'll be right back. I'm not going to show the unboxing because it wasn't very graceful. The P310 has no lack of DC, AC, and USB outputs, that's for sure. It has a built-in lantern right on the back, and I think that's a pretty good idea. The P310 is able to connect to external battery packs, and these are the connectors that would do that. The inverter is rated at 3.6 kilowatts output, and it's got 20 and 30 amp receptacles on the front. This thing is very heavy, but it's nice that it has a built-in handle and you can just roll it around. Well, this is a nice looking machine and I really should get to testing it, but unfortunately for me, whenever I see screws or any electronic device, I just want to open it up. So that's what I did. I'm going to look at the PCB layout and all the engineering and design work inside and check on the build quality before testing the P310. After opening the top of the unit, we can see that the electronics are housed inside of a large metal can with standoffs, and there are 4 DC fans on the side to push the air through the electronics and heat sinks inside. I noticed that the cable and wire management is pretty good. There's a lot of fiberglass wire wrap and everything seems to be glued and held in place pretty well, so that's good to see. These are the AC inputs and outputs. Again, you can see the fiberglass wire wrap. There's glue on everything. They're using a lot of XT plugs for the connections. A closer look at the DC brushless cooling fans. I'm sure they can move some serious air, and I believe that little part there is actually the RF transmitter and receiver for the Bluetooth link. That's the ribbon cable for the front display. All the front panel electronics and control as well as the USB outputs are handled here. Here's our first look at the DC to AC power inverter stage. You can see there's some transformers in there that handle the boosting from low to high voltage. There's some MOSFETs in there, and these MOSFETs are chopping up the low voltage DC into low voltage AC, which then goes to the transformers. Substantial looking aluminum heat sinks, and those look like they should cool pretty well with the fans on all sides. And as I dug deeper into the unit, the MPPT charge controller is revealed. That's what this board is here. You can see the inductor and all the MOSFETs that handle the switching. And I don't see any Japanese capacitors or anything exotic like that, but everything in here looks to be reasonably well made. It's well laid out, well designed. It looks competent, and the build quality looks to be what I would call acceptable. I don't see any problem right off the bat. You can see there that yellow plug is being used for the solar panel input. Now we have the main DC to AC inverter board. This is the DC input side, and you can see that they put 4 40 amp automotive fuses in there just for a safety barrier if anything goes wrong. It's also good to see those capacitors laying on their side have been glued into place so they don't wobble around. And I think this is the control board for the sine wave inverter. And I believe these are the outputs for the sine wave inverter. These are actually IGBTs, and you can look up the part number if you want to. There's some big DC electrolytic capacitors on the DC input of the inverter, as you would expect. This is the AC output side. You can see there's some various filtering components there for the sine wave output. There's also a water intrusion detection sticker that changes color if any water gets in here. That's for warranty purposes. And these are the main DC bus bars coming up from the battery that feed the power onto the circuit board. I have to say that I like what I see so far. Everything seems pretty well done. I decided not to try to dig down to the batteries. I didn't want to cause any damage, but you can see they're cylindrical LiFePO4 cells, and there's quite a lot of them in there. Well, I couldn't find any gripes about the interior build quality of this unit, so I guess it's time to put it back together again and give it a real test, and also hope that I didn't break anything. Well, here we are in the solar room, and I have temporarily rigged up some connections for the P310. Yeah, don't do this at home. Not recommended. It's an emergency situation, so I did what I had to do. And we're getting about 800 watts of solar into the P310. It's important to note that this regulator knob here does not work on solar. It only works on AC. Alright, it's time for a stress test. We're going to use 2 electric heaters, a box fan, and a 12,000 BTU air conditioner. Let's start with that. Alright, let's see if we can overload it. I've got 2 space heaters, and I've got a box fan, I've got another space heater, I've got a vacuum cleaner, and we're pushing about 3,140 watts. Sine wave output looks okay. Alright, let's see if we can overload this unit with a vacuum cleaner. Nope, it's just fine. Okay, this is a full load test. We have 3,526 watts. We have an air conditioner, a box fan, 4 space heaters, and I also have a vacuum cleaner I can turn on. Let's see if we can try to overload the inverter. It did not overload, it just sort of brought the voltage down. Let's take a look at that again. Okay, so we're running the inverter at max power, pretty much. I've got the space heater here, space heater there, a box fan, another space heater, a 12,000 BTU air conditioner, and another space heater. Yeah, it's close to 3,600 watts, so it will not exceed 3,600 watts. It's capped automatically. We're getting 1,000 watts in on the solar, and 3,500 watts out. Okay, let's try the overload test again. Okay, so this inverter will not overload. It is protecting itself by dropping the output voltage. Let's take a look at the sine wave again. I'm going to try to overload it with the vacuum cleaner. So the sine wave inverter in this machine has exceptionally stable output. I'm very impressed. Most high-frequency inverters that I test, they just don't behave this way at all. This is somewhat impressing me. The inverter is definitely strong, and it definitely protects itself. It's able to maintain a clean sine wave even when I'm pushing it extremely hard and maxing it out on purpose. Okay, so I'm doing a sustained high-power load test, and so far so good. And the box fan, I'm actually running 4 space heaters as well as an air conditioner. It doesn't make a lot of sense to try to push it beyond 3,600 watts because it will not do that. It doesn't allow it. So this unit has a protection system built in that prevents anything more than 3,600 watts from being pulled out of the inverter, which is fine. It's just a different way of providing protection. Basically, it just drops the output voltage, and that's fine with me, just as long as it has protection. Now remember, when both charging and discharging, there's a lot of heat produced. We're getting about 950 on the input, 3,500 on the output. This machine is doing quite well with heat management. You can hear the fans running. They're not too bad. I don't begrudge them putting fans in there. You need those to cool something like this. It's good engineering to have fans blowing and getting all that heat out of the case, so I'm not going to complain about fan noise. Also, I'm running a box fan, so that's part of the noise. And you're also hearing this thing here. That's causing a lot of noise. Yeah, there's quite a lot of warm air coming out the side, which is not surprising. Yeah, it's getting pretty warm. I wouldn't say anything dangerous. Quite a lot of heat being produced inside. 130 degrees Fahrenheit. Okay, we're still here. I gotta say, this machine is impressing me. It has not fallen over. It has not failed the test. It's handling pretty much the maximum output non-stop, as well as a kilowatt of solar on the input, more or less. And that's pretty impressive. I can't really find fault there. The sine wave output on this machine is very, very good. It is far better than other high-frequency inverters I've tested that were discrete components. It's keeping such a clean output even when I try to push it, even while running inductive and resistive loads at the same time. Okay, so I turned off the box fan and the space heater that has a fan built in, so you can hear what the solar generator sounds like by itself. And yes, it does have quite a powerful set of fans in there. Still pushing 3.3 kilowatts. Anyway, this thing is a Mack truck. It's just pushing on through. I can't really find fault with the performance of it at this time. After powering down some of the loads, the P310's fans start to ramp down almost immediately, and they're already getting a lot quieter. So obviously they do care about the thermal characteristics of this unit, but also the acoustic ones, because people complain about fan noise all the time. It's dropping down to 680 watts. You can hear the fans getting slower and slower. So yeah, I like that. The fan curve is very responsive, and they obviously pay a lot of attention to that. I can still hear the fans, but they've faded down to like 80% of what they were. So let's do an after-action report. I pushed this thing really hard trying to overload it, and it's protected itself from all attempts to overload. So that's actually a good idea. Basically, it's very simple. If you overload it, it'll drop the output voltage, but it maintains a smooth, clean sine wave. That's one way to do it. There are other ways. I don't have a problem with that. I did not try shorting it out or anything. I just plugged in too many things into the outlets to see what would happen. I do not have a 30 amp power strip to plug into that receptacle down there, but I don't need to. I was able to achieve maximum output using just the 20 amp receptacles on the left side. It would have been nice to have a 30 amp power strip, but I just don't, and there's nothing I can do about it right now. The P310 can run this 12,000 B2 air conditioner all day long without any problem whatsoever. So just a reminder that I don't get paid per sales of this unit or for saying anything in this video. My intent is to share my expertise and my experience and then let people think for themselves. I'm not an influencer, and I hate that term. In all aspects that I consider, the P310 looks like a pretty serious piece of engineering, and it seems like it's fairly well made. Like any piece of complex electronics engineering, things could go wrong, and a long-term test would be a better way to determine whether it has good durability and longevity. But after several days of testing this machine, it has not blinked. It has not given me any trouble. It doesn't have any problem whatsoever running a huge number of loads, as well as being maxed out for a period of time. I don't recommend running equipment like this at 100% capacity for extended periods of time, but it appears to be capable of doing that. Assuming that this machine can last 2 or 3 years of normal use patterns, I have no problem recommending it. In my tests so far, I have not uncovered any major faults or flaws with the P310. I hope it lasts and is durable, and I think I can recommend it if you're interested in this type of machine. And did I mention I don't get paid for saying that? Look, when you're buying any kind of complicated machine like this, check the warranty, do your homework, make sure there's support, and be advised that it can always fail. And a thanks to Aferiy for sending this unit to me, and also to our friends and subscribers for watching this video. I hope you enjoyed it. Thanks for watching, and I'll see you next time.